Right, so our last section for this week is 12.3. Okay, solving word problems using two variables. Okay, so I just said earlier in the year we solved problems with one variable. Now we're going to solve problems with two. All right, so the two letters, you usually can pick whatever you want. A lot of times if they gave me a problem about, like, say, Bill and Mary, I'd probably use B for Bill, M for Mary. The only letter you probably want to stay away from is if you had something beginning with an O. Probably not a good idea to use the letter O because it looks like what? Looks like 0. All right, so here's your steps to solving two variable equations. Okay, step 1. Okay, choose the letters that you want to use. And when we say explain what they represent, you could do something like M equals Mary. That explains what M is. Just tell me, oh, M is Mary, H is, Hank, whatever. So then I know which letter is which person. Okay, if we have a problem that has two people that their names started with the same letter, like Mary and Matthew, well, then we can't use M for both. We'd have to do something different for Matthew. Okay, but in general, we'll try to avoid that. All right, so after you pick your two letters, then we have to write two equations. These are going to be the equations that we solve. So on the homework, you guys never had to make up your own equations. Every problem was already given to you because there were no word problems. Okay, so we're going to write our two equations from the information they give us in the problem. Okay, they'll give us a couple sentences. In those sentences, we're going to have to look for keywords like is. Anybody remember what is means? Equals. Okay, so is. You might see like more than. Okay, what operation is more than? Adding. Or fewer than. That would be subtracting. Things like that. Okay, so we're going to have to look for those keywords. So now we're going to give you kind of a couple hints on how you write the two equations. Okay, so your first equation, okay, comes from the first sentence in the problem. Okay, pretty straightforward. First equation is going to come from the first sentence. Usually it's going to be in this kind of format. It's going to be one of your variables plus the other, or minus, equals a total. For example, let's say I said, what were the two people I used up above? Mary and Hank. Okay, let's say I said the sum of Mary and Hank's ages is 40. If you add their ages up, you get 40. What does sum mean? Addition. So if I said the sum of Mary and Hank's age is 40, that's how you could write that as an equation. If you take Mary's age, add it to Hank's age, the answer is 40. Okay? That's what your first equation is usually going to look like. Okay? That one's usually pretty straightforward. Okay? The only time it could be even easier than that if it's about a rectangle problem. Okay? If it's about a rectangle problem, you don't really need to think about what the equation is. This is always the equation for a rectangle problem about perimeter.
So make sure you guys write that in.
2L plus 2W equals P. Okay, so it is kind of nice when it's about a rectangle problem because then you know your first equation right away. You don't have to think about it too much. You use this. What they'll usually do is tell you the perimeter. Okay, they'll say the perimeter is 50, and you'll fill in perimeter. Okay? You won't know the length, you won't know the width, but you will know the perimeter. Okay, the second equation comes from the second sentence in the problem. This equation, we can't really be any more specific. It depends on the problem. You have to read it, and it's a little different every time. Okay, so
Guys, usually in that one, whenever, like Mr. Hager said at the beginning, like B is Brian, H is Hank. One of those things is going to equal, it might be B equals 2H minus 5. Right, so one of those single variables is going to equal something.
Right, so after we get our second equation, now we're going to, step 3A is what we've done yesterday and the day before. We're going to plug in using substitution, and now we're going to solve the problem. Okay, so from this step on, it's what you guys learned yesterday and the day before. Okay, so we're not going to write out all the steps for how you plug things in, distribute. Okay. But after you do step 3A, you're going to know one of your letters. Okay. How many letters are we usually solving for?
If you have a system, how many letters will there be? Different letters.
2.
Good.
Okay. At step 3A, you will know one of them. Okay. What do you do once you have one of your answers? You take it and do what with it? Yeah, you're going to plug it back in. You're going to take the answer that you just got from step 3A, plug it back into the other equation, and solve it. Now after step 3B, you'll have your second answer. Okay, and the fourth step, we can always check our answer to make sure it works. Okay, if we have time, if we want to do that. I don't think I'm going to check every problem today. We're only doing 3. But maybe I'll check the answers in one problem.
Sorry, those data ones that you talked about for homework that you don't finish?
So we're going to do 3 problems together in class, and then you'll have 3 problems for homework.
Okay.
Yeah. So we'll definitely finish the 3 in class. I don't know if we'll finish the 3 for homework, though.
I think the MCAS one, guys, will probably finish in class, so you might have this to do over shop week, if any.
Okay, anybody still need to copy down?
Yeah.
Right, so the first problem we're going to look at is going to be set up very similar to your MCAS question. You guys don't have the MCAS question yet. I have them up here. Okay, but it's going to be the next problem is very similar to this one. All right, do you guys have example 1 already written out on your notes? You got it? Okay. All right, so example 1 is going to have to do with a butcher selling 2 different kinds of meat. Okay, so there's going to be our variables. Okay, the 2 types of meat. It said, can I make this bigger on the right so everyone can see it?
Yeah.
Okay. Okay, it says a butcher sells 20 pounds of meat. The butcher sold 2 kinds of meat, sausage and ham. Okay, so sausage and ham, that's going to be what we're going to be thinking about when we want to pick letters for our variables. What letter could we use to represent the number of pounds of sausage that the butcher sold? What would be a good letter for that? Logan?
M,
Okay, tell me why you picked that letter.
because for meat. And then your S might look like a 5, so you should put M for meat.
Now we're going to do sausage and what's the other one? Ham. That's meat too.
So H.
I would probably use H for ham. I think that's good. I agree with what you said. If you make your S like that, it would look like an S. I think if you made it like that, it could look like a 5. So you want to use M for sausage? Okay, we could do that. What letter will represent sausage? M. Okay. What letter would represent ham? Right? Yeah, H would be a good letter for that one. I don't think the H, you'd confuse that one with a number. So, since we had a choice of what letter, we're not using X and Y. We didn't choose those letters. Okay? So, we're using M
That's what's cross those out, guys.
and H. Okay? It says, write an equation that can use to represent the total number of pounds of meat that was sold. Okay? First of all, when you see the word total, how do you total something? What operation is involved when you're totaling? Addition. Okay, you're adding things up. Okay? Now, we already know the total number of pounds of meat that was sold. Okay, if you read that question, how many pounds of meat did the butcher sell? 20. What we don't know is, did he sell 1 pound of sausage and 19 pounds of ham? Did he sell 10 pounds of each? Okay, that we don't know. So how did we represent the number of pounds of sausage? M. So he sold M pounds of sausage. And how did we represent the number of pounds of ham?
And H.
H. So all we know is if we take how much sausage he sold plus how much ham he sold, it's a total of 20 pounds. At this point, we don't know how much of each. We just know it adds up to 20. Okay, any questions on our first equation? That's it for our first equation. So we're halfway done what we need. Okay? Yep. Now we need one more equation.
And guys, usually that first equation is going to be two variables added or subtracted equal to a number. There'll be no numbers or anything with the variables.
All right. So a lot of times when we're dealing with this kind of problem, one equation is about the amount of stuff you sell. Okay, 20 pounds. The other equation is about the cost of it. Okay, so one equation is about how much. The other equation is about the money. What did it cost? Okay, and it says here sausage, I'll just put that there to remind us, costs $3 per pound. Ham is $5 per pound. The butcher sold a total of $80 worth of meat. We're going to write an equation that represents the cost. Right? Now, we already know the total amount in terms of dollars. What was the total amount of money that the butcher made?
$80.
He sold $80 worth of meat. We don't know, did he sell $10 of sausage and $70 of ham? We don't know that yet. But we know he sold a total of 80. All right. So now, sausage costs $3 a pound. Let's just try an example. If he sold 1 pound of sausage, how much money would he have gotten from that? $3. What if he sold 2 pounds of sausage? How'd you get 6? What'd you do with 2 and 3? If you add 2 and 3, you get 5, not 6. How'd he get 6 from 2 and 3? You times them, right? What if What if the butcher sold 3 pounds of sausage? How much money would he have made? 9. And what's 3 times 3? 9. Okay, we'll try one more. What if he sold 4 pounds of sausage? 12. And what's 4 times 3? 12. Okay, so now in general, what if he sold M pounds of sausage? What would you do with the M and the 3?
You put 3.
3M, perfect. You take how much it costs per pound times how many pounds he sold. Okay? When I asked you guys specific ones, you did 3 times 1. Victor did 3 times 2. If we sold M, it's 3 times M. Okay, I could put 0.00, but I don't need it. If it's zeros, we don't have to worry about it. All right, now ham is $5 a pound. What do you think I'm going to put right after the plus sign?
5H.
5H. Okay. If he sells 1 pound of ham, 5 times 1, he makes $5. If he sells 2 pounds of ham, 5 times 2, he makes $10. Okay. This is your second equation. Okay. At this point, we are done making our equations. Now it's like a problem we did yesterday. We just need to solve. But any question on that second problem?
Yes, like Mr. Hager said, he just took how much it cost and then added the variables to it.
Now, if I wanted, can I use different letters in the second equation than I did in the first equation? What do you think? Could I use like X and Y in the second equation and M and H in the first one?
No.
No. You can't have 4 different letters. You've got to pick 2 letters and use those 2 letters for the whole problem. You can never use more than 2 letters. Okay? All right, so let's try the last step. Okay? Use the 2 answers we had up above to determine exactly how many pounds of sausage and how many pounds of ham the butcher sold. Okay, so now when we're done, we're going to say he sold exactly this many pounds of sausage and this many pounds of ham. Okay. What I'm going to do so you guys can see it, I'm just going to copy down our 2 equations. M plus H equals 20. That's how much stuff the butcher sold. 20 pounds of meat.
I think he sold 5 pounds of beef sausage.
And 3M plus 5H equals 80. That's the cost of what he sold. Okay. So now I have 4 choices. I can either get this, 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 or that by itself. But I've got to get one of those letters by itself. Which equation here do you think is easier to get a letter by itself in? Top or bottom?
Top.
Yeah, definitely the top. Do you think it matters in the top which letter we get by itself? Not really, because there's a 1 in front of the M, there's a 1 in front of the H. I'd say either one is fine. Okay, so which letter do you want to get by itself? Pick any letter. Okay, we're going to get H by itself. Can somebody tell me how would I move the M to the other side? Subtract it. Okay, so subtract the M. Subtract the M. That's gone. And I get H equals what's going to go in that box? Oh, Court? What's H going to be equal to? 20 minus M. Good. Okay, any questions on how we got H equals 20 minus M? Okay, don't think about it in terms of sausage and ham anymore. Just think about it, okay, we have 2 equations. We just have to solve them. Okay, we can forget about the word problem now. Okay, so all we're doing is moving the M to the other side by subtracting. 20 take away M on the right, and then H on the left. Okay, now what do I do with what's in this box? Where is this 20 minus m going to go? It gets plugged in somewhere. Yeah? We're going to plug it in for the h right there. Right? So we're going to take what we have for h from the first equation, and we're going to fill it in for h in the second. This is exactly what we did yesterday and Wednesday. All right. Is anything going to change with the first part, the 3m? No, that stays the same. Okay, when I plug in for h, what do I always want to make sure I write down? Parentheses. Okay, so before, we had an h next to the 5. Now you're going to fill in for h. Okay, Ben, what am I filling in for h?
20 minus m.
Perfect. 20 minus m. Okay, is there anything else I need to keep writing? Still missing something here.
You need to put plus 80.
Equals 80.
I mean, even.
Yeah. Okay, now look at this equation. What's the only letter that's in this problem now? M. So once we're done, we're going to solve this equation. We're going to know how many pounds of meat the butcher sold. How many pounds of sausage. Okay, we'll know the sausage. We won't know the ham yet. But once we know sausage, the ham is very easy to find. Just subtract it from 20. Okay, what do I do for my first step here? Yeah, we're going to distribute the 5. Okay, and I'll help you guys with that. 5 times 20 is 100. 5 times negative m, negative 5m. Okay, do I have any like terms on the left-hand side? If I do, we're going to combine them. Yep, the 3m and the negative 5m.
So you subtract 5m.
So 3m minus 5m. Okay, what is 3m minus 5m? Negative what? Negative 2m. 3 take away 5. That's negative 2 with an m. What's still on the left-hand side? 100. What's still on the right side? The 80. Okay, two steps left to get m by itself. Kevin? Yep. Good job. You're going to subtract 100. Okay, 100 minus 100, that's gone. And what's 80 minus 100? Negative 20. And my last step to get m by itself, right? Divide.
Divide negative 2 by negative 20.
Divide. Can you say that one more time?
Divide negative 2m by negative 20.
Negative 20. The negative 20 is okay. We want to get rid of the thing that's next to m.
Ryan, under that negative 2m, when Mr. Hager drew that line, what do you want on the right?
Negative 2m.
Okay. How about just negative 2? Is that okay? All right.
So you want to divide by the coefficient of m. Okay, what's in front of m? How many pounds of meat, or how many pounds of sausage, sorry, did the butcher sell? Zach? 10. Okay, so is that good? Is that the only answer we need? No. This is just the sausage. How do I figure out ham? Yeah, plug it back in. Okay. You've got a formula right here for ham. Ham is 20 minus m. So ham is 20 minus, what was m? Yep, 10. And what's 20 minus 10? 10. Okay, so in this problem, it's just a coincidence that they came out the same. Okay, it could have come out that he sold 12 pounds of sausage and 8 pounds of ham. Okay, but in this case, they were both 10. Okay, any questions on setting up those equations or solving them?
And guys, that one, I mean, is really spelled out. The ones that you're typically gonna get aren't gonna be like spelled out like that, like set up an equation using the variables. But the MCAS one we're gonna give you is set up like that. Right? That's the only time they'll have one really set up like that, really broken down for you. Other than that, it's gonna be the word problem, and you have to set it up and solve it.
Okay, so does anybody have any equations on setting those up or how we solved it, the algebra?
Can somebody tell me, guys, what's that? How are we gonna set up that first equation that we set up for the system? Typically, what's that gonna be? How's that gonna be set up? It's gonna be equal to the what? Anybody remember what we said? If I have, 30 red and yellow jelly beans, all right? I don't know exactly how many I have, but how would I represent that? If I have a total of 30 red and yellow jelly beans, how would I set it up? Using two variables. Say, huh? R, perfect. R, Y, yeah, R and Y. R plus Y equals 30. You know how many of each there are, so it's R plus Y. You're just taking those first, typically it's going to be those first two variables, all right? Whatever you decide what's going to represent each thing, add them together, equal the total amount that you're given. The second one is when it gets a little tricky, all right? The second one's when you have to use information from the problem to set up your equation.
Okay, so we'll do one like Mr. Roy just said after, but this one's actually a little different. It's a perimeter problem. And when you have a perimeter problem about a rectangle, the first equation you really don't have to think about. Okay, we wrote it in the notes. Can somebody remind me what that first equation always is when you're dealing with a perimeter of a rectangle? Anyone have it? Yep. Yep, so she said 2L plus 2W equals P. This is always your first equation. Okay? The only thing you have to fill in for is P. So if you read that first sentence, do they tell me the perimeter?
No.
What do they say the perimeter is?
54 centimeters.
The perimeter is 54 centimeters. That's your P. Okay? Fill in 54 for P. Okay, so equation 1, I'm just making a spot, so I'm going to write it down. It's going to be 2L plus 2W equals, what's the perimeter? 54. Okay, that's it. There's your first equation. Okay, if that's all they told me, I wouldn't have enough information to find L and W. So they give me another sentence. The length is. Okay, let's just start with that. Okay, our letters have already been chosen for us. What did we choose for letters? We chose L and we chose W. Okay, the first part says length is. Can somebody tell me how you'd write that as an equation? Think about what letter we use for length and think about what is means. Length is. Justin? Okay, what equals? Length is. So this is just is. Come on, length is. Anybody help him out? Yeah? So length is. Think about length. What do we use for length? What letter? L. Length is. That's it. That's the first part. Length is something. Now we have to figure out what it is. Okay, that's the rest of the sentence. The length is 1 centimeter shorter than 3 times the width. Okay? Start with this part. 3 times the width. Okay? Anyone think they can tell me how to write that? 3 times the width. Rose?
3W.
3W. Okay, now it doesn't say the length is 3 times the width. It says the length is 1 shorter than 3 times the width. So put a -1 on it. And that's it. That's our second equation. The length is 1 centimeter shorter. Okay, shorter means you get a -1, 3 times the width. Okay, a mistake here that sometimes Mr. Roy and I see is people put the 1 first. Okay, they accidentally switch this order. Okay. Remember, if it's something is shorter, like by a number, we usually put the number by itself at the end. We put the number with the letter first, like the 3 and the W. Okay. All right, so now looking at these equations, do I have a letter by itself here?
The L,
Yeah, L in which equation?
the one below it.
Yeah, the one in the bottom. So what is L equal to? So everywhere we have an L in this top equation, we're going to change it to what? Exactly. Now we're just going to go through and solve it, just like we did the last one. So L equals 3W minus 1. Change L to 3W minus 1. Okay, so we've done the hard part. I think the hard part is just getting your equations. If you can get these, now it's just like what you did on the test. All right. So I'm going to put a 2, and then what do I always want to put when I plug in? The symbol. Yep. Always put your parentheses. And for L, Sam, what am I filling in?
3W.
Yep. 3W minus 1. Okay, nothing else here is going to change. Okay. Don't forget the plus 2W. That doesn't disappear. That's still there. Don't forget the 54. That doesn't disappear either. That's still there. Now you've got an equation with all W's. So when we're done, we're going to know the width. And then we'll find the length. Okay. Somebody distribute that and tell me what you get. So anybody figure out what you get when you distribute that to? Logan?
You get 6W minus 2.
6W minus 2. Okay, don't forget about the 2W, that's still there. Okay, don't forget about the 54, that's also still there. Okay, what's my next step? What am I going to do with those W's? Yep, we're going to combine them. Michaela, can you tell me what 6W plus 2W is? Yeah. 8W. Okay, again, don't lose that minus 2. And don't lose the 54. All right, I got 2 steps left. What's my second to last step? Well, Alexis? What do we do next to try to get W by itself? We're going to do add 2 where? Yep, to both sides. You're going to add 2 and add 2. That's gone. 8W is still there. We didn't get rid of the 8 yet. And 54 plus 2 is 56. And Callan, what's my last step to get rid of the 8? Yep. Divide by 8. Divide by 8. And let's just type in 56. Divide by 8. We get 7. So what is 7 here? That's my width. If you pick a letter that is easy to remember, you can easily remember, oh yeah, W was width. If you picked like K, probably wouldn't remember K is width, so that's why we try to pick a letter that makes sense. And it's centimeters. Okay, so I'll just put centimeters. Okay, so I got my width. What else do I need?
Need length.
I need my length. Okay. Do I have an equation that has L by itself? Do I have a formula for length? Yeah. The length is triple the width minus 1. Okay. So take your width. Okay, fill in for the width, triple it, and then minus 1. And that will be your length. So, Gavin, what?
Still the same thing, even if you use a top problem.
What's that?
I use the,
You plug 7 back into the top one?
yeah.
Yep, if it comes out the same, that's how you could check it. If it came out different when you did each one, then something's not right. So what Logan is saying, if you plug 7 into the bottom one, or you plug it into the top one, you should get the same answer for L. If you don't, something's wrong. I'm picking the bottom one because I think the bottom one's easier.
Yeah.
There's less stuff there. Okay. So what are we filling in for W? So 3 times 7 minus 1. What's 3 times 7 minus 1? 20. And that is my length. Okay, so my width is 7, and my length is 20. Right? And if we had these two numbers, it would make everything here work. You could check it. The perimeter would be 54, and the second equation, everything works perfect. Okay, so any questions on that one? Okay, a little different than the MCAS one because the first equation is basically giving to you that 2L plus 2W. Okay? I like the rectangle problems because of that. I don't have to think about the first equation at all. Okay? In the MCAS one, I did. Okay, I had to figure it out. Okay, anything else on this one before we look at our last problem? All right, so last one. Okay, and then we'll have some time, I think, to start homework. Okay, it says Bob is 11 years older than Hank. That's going to give us our first equation. The sum of their ages is 27. That's going to give us our second equation. Find out how old they are, each one of them. Okay, so start with the first equation. Bob is. All right? Actually, you know what? Before I even write an equation, I need to pick my letters. What do you think we should use for Bob?
B.
All right, so for Bob, we'll do B, or we could do capital B, it doesn't matter.
Yeah, capital B so it doesn't look like 6.
And for Hank, good letter for Hank would be H. Okay, and when I'm done, I'll put my final answers right there. All right, so it says Bob is. Okay, how would you write Bob is? As an equation. Bob is, yep. Good, Bob is. Now, this is the key phrase we have to interpret. Older. Okay? Older is kind of like saying more. 11 years more than Hank, or 11 years older. So what operation do you think we use with older? We're going to add. Okay? 11 years older than, 11 years more than Hank. So what am I going to put right between the equal sign and the plus?
11.
An 11? And Bob is 11 years older than who?
H.
Hank. Right? That's it. That's equation 1. And look what happened. You already have a variable by itself. B. Okay, now our second equation. The sum. Okay, before we write anything else, what does sum mean? addition. Sum means addition. So we're going to add two things. It says the sum of their ages is 27. We're adding their ages. Okay. Who are the two people we're going to add up? We're going to add Bob's age to Hank's age. And if you add their ages up, what's the total? It adds up to 27. Okay, and there's our second equation. Okay, what's actually nice about the second equation, there's no number in front of B, there's no number in front of H, which means you're not going to do distributive property at all. Okay, any question on that second equation? All right, so now I think I already asked this. Do I have a letter by itself? Victor? Yeah. Yeah. What is B equal?
No, it's an H.
H.
Yeah, see, I can't see, but I don't have my glasses on.
All right, so B is 11 plus H. So where am I going to fill in 11 plus H?
Oh, you're going to put 11 plus 8, wait,
I'm going to fill it in for
B.
B. Yeah, we're going to put it right there. So take what B equals, 11 plus H, and fill it in for B. Okay. Yep, we could still put it in parentheses. We don't have a distributive property this time, but it's not wrong to do that. Okay, who can somebody give me my equation?
B 11 plus H.
11 plus H.
We use plus H still.
Yep, you still have that plus H. That doesn't go anywhere.
27.
Equals 27. Okay, what's 1H plus another 1H? 2H. All right. And 2 steps left, and then I'll know how old Hank is. What's my next step? Good. Subtract 11. Subtract 11. What's 27 minus 11? 16. And my last step to get H by itself. We have a 2 times H. We want to get rid of this 2. Yeah, we're going to divide by 2. So, how old is Hank?
8.
Hank is 8. Okay, and I think I said I would write that up above, so I'll just copy it up there. Okay, so now I know Hank's age. Whose age do I still need to find? Yep, so I'm going to get Bob. How do I get Bob's age? What am I going to fill into? My first equation or my second? I could do either one, but the first one is easier. Okay, what are we filling in for H? Yep. Bob is 11 plus 8. So how old is Bob? 19. Right, so this is the kind of problem that if you just look at this information and you try to start guessing in your head, like, wait, their ages have to add to 27 and Bob has to be 11 older, it's kind of hard to guess. But if you set up equations and solve it with algebra, it actually becomes very simple. There's no guessing. Now, keep in mind, all these numbers came out nice today. If you got answers that were decimals, then it's almost impossible to guess. Like if like the butcher sold 2.7 pounds of ham and 9.6 pounds of sausage, you'd never guess that. So you got to set up your equations. Okay. So any questions on that? That's systems of equations with word problems. Okay. The reason Mr. Roy and I wanted to get these done now is because if we didn't do them now, you got the break next week and then you got shop week. I don't think substitution would be too fresh in everybody's mind. All right. So now we did substitution. We did substitution word problems. Next time you guys come back, we're starting something new. So we don't have to remember really what we did here to do the next thing, which is good. Yeah, it's pretty straightforward.
This looks so easy.
All right, so this is your homework over shop week, which you're going to have about 15, 20 minutes to start now. Okay, we're going to give you an MCAS open response and 2 word problems. Okay, my suggestion would be try to get them done now while this is all fresh in your mind. You can probably do it 5 times faster right now than you'll be able to do it 2 weeks from now. All right, so we'll work on these in class, and I'll come around and help you guys out.